Hello everyone. Today the problem statement which I brought for you is finding the squares of a sorted array. I will be solving this and explaining you using the two pointers approach which we have already discussed in a previous video. You can consider it as another example of two pointers. Coming up to the question first, we'll just figure it out what is this question and what is its output. First we'll be solving it with brute force approach and then we'll see if we can optimize it. So as you can see the question, it is like you have to find the squares of sorted array. Means you have been given a sorted array and what you have to return is the square of this sorted array. But the catch over here is that when you are returning the square of the sorted array, it should be also sorted. Means if you see the question, it is nothing but you are having an array. An input has been given to you. What do you do is you square all these elements of this particular array and store it in a new array. So you will be taking a new array and you will be storing the square of this particular given input. So minus 4 becomes 16, minus 1 is 1, 0, 9 and 100. This what you have done is you have done the square of this particular element. But how is the output? Output is again in a sorted form. Means secondly what you have to do is you have to sort this particular thing and after sorting you get the result in the form of 0, 1, 9, 16 and 100. So this is the basic question and this is nothing but your brute force approach. What we are doing in the brute force approach over here is first you square all the input data in a given array. And as you square, what you do is you store it in a new array. And the third thing what you do is while you are storing, after storing, what you do is you just sort this new array, sort the new array. So in these two things, as you have taken a new array, your space complexity directly becomes big of n. Coming up to the time complexity, since you are traversing the whole array to find the square of the elements, so for finding the square of all the elements, it will be big of n, and when you go for sorting, it will be nothing but big of n log n. So the time complexity of this particular question using brute force method will be big O of n log n. Now if I say that try to optimize this particular question, it means that we have to see to some other approach or alternative algorithm where we can reduce this time complexity to big O of n. This is what we have to do for optimization. So for optimization, what we are doing is we are using the two pointers algorithm and solving this question so that we get a time complexity of big O of n. So coming up to the two pointers approach, what we have seen in a previous video was that whatever array or a linked list is given to you, we use two pointers, and what basically happens over here is the placement of the pointers. How you place the pointers in the given array so that by its movement you will be getting your desired output. So here what is happening, I'll be taking the same example. You have been given an input array. So it's -1, -4, -1, 0, 3 and 10. Same thing, what we have to do is we have to find the square, and what we are returning, so same thing, what we have to do, we have to find the square, and what we are returning the squared data of the sorted array, but when we are returning, it should be also a sorted one. So to return or to store the squared data, again the same thing which we have seen in the brute force method also, you require a new array. Now what should be the size of the new array? Equivalent to what the input array is. So nothing but this is my result array. So how do we use this two pointers approach and how it works? We'll just see the movement of the pointers and then we'll code this. So what I'm doing is I'm placing the first pointer left at the 0th index and the right pointer at the end of my array at the 4th index. So here what is happening, the left pointer will be moving forward and finding out the positive numbers, whereas the right pointer will be moving backwards to find out the negative numbers. Now why we are going for this concept is because this, if you can see the input, it is a combination of negative and positive numbers. So when a negative number is squared, what will be happening is you get the value higher than the any smaller positive number. That's the reason you will be having two pointers so that it tracks the negative and the positive numbers over here. So how we do? It's very simple. You just take two things to store this left data, that is nothing but square left data, and another variable you take to store the square right data. And as this movement is done, you compare and you place the result data in this particular array, new array. So in the square left, what you are doing, wherever the left is pointing, you pick up that element and you square it. So I first left it as 0, so I just take the values and I'll be finding the square of it. Next, what I am doing, I take the right, whatever value has been pointed by that, I just square that value. Once you get the square, now which value to be placed and where to be placed. For an example, if I see, okay, 16 is smaller than 100, so I place 16 at the very first index. What will happen is my output will be wrong. Why? Because when my pointer moves, suppose my pointer now moves to the next element, that is minus 1. So minus 1 and 1 minus 1 square will be giving me as 1. So what will happen? It will be less than this value of 16. So what we do over here is we don't store the data from the first index, but we start storing the data from the last index. Now how it is? You will be having one ith pointer which will be nothing but placed at your n minus 1. N minus 1 is nothing but n is your size of the array and minus 1 will be giving you the last index number. So as you hold this, what is happening? Right will be always moving from the greater positive value. So whatever square will be, it will be greater. If at all, in place of minus 4, you had minus 11. So what happened? Minus 11 into minus 11, the square value will be more than the 100. So at that time, we have to decide what value. You have to store the right value over here or you have to store the left value over. That's the reason that's the reason we start from the very last index, so that whenever we are storing the data in a sorted manner, the greater value is stored at the end and you move to a lesser value over here. So what is happening? First thing, you have found the square of the element, and in the second stage, what we do is you compare. You compare square left and square right. So as you compare, if my square left is greater than square right, I'll be putting this value in the last index which is pointed by I, and Since I am using the left pointer's value, what it will be doing is, will be moving the left pointer over here. Similarly, if my square right is greater, that value will be stored over here and I'll be moving my right pointer. So in this scenario, in this case, if my square left is greater than square right, my square left value is being stored, and where it is stored? It is stored in the new array named as result. And what will be the index number? Index number is nothing but given by I. So this is what happens, and as soon as you see that the left value is stored, we will be shifting our left pointer if this condition is true. Similarly, if the condition is reversed, like my square right is greater than my square left, so what I will be doing? Simply I will be storing the square right value and I will be moving my right pointer. So this is what happens in the compare section. So if you just see this, as you have got square left value as 16 and the square right value as 100. So when we go for comparison, what we are comparing? We are comparing 16 and 10. So for an example, in place of this, 16 is greater than, 16 and 100, not 10. So 16 and 100 has been compared. So this condition goes false. So we directly come to our else condition, and square right is nothing but the value 100. 100 is stored where? 100 is stored in the new array with the index number that is pointed by I. And where is my I pointing now? I is pointing at n minus 1, nothing but at the 4th position. So what I am doing? I am storing 100 over here, and my right is being decremented. So my right is decremented and my right moves over here. So this is the basic concept of this particular question. So we'll just see the movement and then we'll code this question. So what happened is, my right moves over here, and similarly my I will be decremented. So I comes here. Now again what is happening? We compare left square is nothing but 16, whereas my right square will be giving you 9. So I'll just write over here, left is giving you 16, whereas your right pointer it is giving you as 9. You go for the comparison again. If square left is greater than your square right, so yes, here I found that my square left is greater. So this value will be stored in the position where I is pointing. So I is pointing in the 3rd index. So 16 is stored over here. And since this value is being used, what is happening? We move that particular pointer and left is incremented. Similarly, what is happening? There will be a movement in I and I is decremented. So I comes over here. Now what happens? In the 3rd iteration, my left is pointing at minus 1. So minus 1 and minus into minus 1 gives you 1. Whereas right, 3 into 3 gives you 9. Now you compare 1 and 9. Is 1 greater than 9? No, 1 is not greater than 9. So what happens? My 9 value will be stored in the result ith position. So 9 is stored, and where I is pointing at 2. So 9 is stored over here. And as you have used the square right value, what happens? My right pointer is moved. Similarly, my I is also decremented. I comes over here. Now you pick up the values again. Your left is already 1 and your right is 0 into 0 gives you 0. You check 1 is greater than 0. Yes, you find 1 is greater than 0. So value 1 is being stored at the ith location. So 1 is stored over here and your left pointer is incremented. So you come here. Now what is happening? My left pointer is pointing at 0. So I have 0 and right is also pointing at 0. So 0. You check, is 0 greater than 0? I'm not using any equal to over here. So what happens? This condition goes false and you come to the else. So 0 is stored where I is pointing. I is pointing at the 0th index. So my 0 value is stored over here and my right pointer is decremented. While right pointer is decremented, what is happening over here? my I is also decremented and it comes out of the condition. Now what should be the condition? Since I have started I is equal to n minus 1, so I will be moving up to the very first index, that is nothing but 0. So it will be showing the condition of I is equal to greater than or equal to 0. Since this condition goes wrong, you come out of your whole program and you return this result. So now what is the result I have returned? I have returned the result which was actually my desired output. If you can see, it is 0, 1, 9, 16 and 100. So this is the way of doing this question. So while doing this question, what is happening? I has been iterated from the last index to the very first index. This is the traversing of your I, and left and right, how they are moving? They are moving based on the negative and the positive numbers. So only once you are iterating the whole input data. So nothing but once, if you are iterating only once the input data, the time complexity will be always big of n. So this is how you can optimize this particular question and you can get the time complexity of big of n, whereas the space complexity remains the same. Why? Because we are using a new array over here. So the space complexity is your big of n. So this is the way how you use the two pointers approach to solve this question. Now we will be writing a code and see the dry run for that. So now what we will do is we will now work on the second example. So the second example that has been given to you is minus 7, minus 3, 2, 3 and 11. So this is nothing but your array given to you, that is nums. So what is the size of this array? The size of this array is nothing but 5. So my new array that I am using to store my result, its size should also be 5. So as you start the code, you are finding the square and nothing but an array is been passed to you. So I am just taking a vector over here as a parameter. And since you have to return a new vector, so the return type is also a vector. No. So for very first thing what we have to do is we have to take a new vector to store the value, and the size of this new vector should be equal to the size of your input array. So nothing but if I find we can find out the size, we can write it in any ways. And now you just take a new vector to store the result with the size n. So this is the very first thing which we have done. You have taken a new vector to store the result. Now you start with your pointers, initializing the pointer. So since we are having two pointers, we initialize 2 pointer over here. Left pointer is initialized as 0 and then the right pointer we initialize at the end of the array. So end of the array is nothing but n minus 1. So this is what we get over here. So left has been pointed over here and right has been pointed over here. Since we have to traverse the whole array, we start traversing using a loop, and as we have seen that we will be storing the data from the very last position. So I take it as n minus 1 and the condition will be up to the very first index number, that is nothing but 0, and while doing this we will be decrementing the ith value. Now after starting with the iteration, in each iteration what we have to do, we have to square the left value, we have to square the right value, and then we have to compare. So we will start with that. You take a variable square left to store the value of the. So what we do, we take a new variable square left, and this will be storing the square of the values that is pointed by the left pointer. So left pointer is pointing the array that is nothing but nums. So nums left, square of that. Similarly, what is happening? We are taking one more variable that is square right, which will be storing the square data that is pointed by the right pointer. Nums right. After finding the square data, what we have to do? We have to go for comparison. So we just go for the comparison. If square left is greater than square right, what is happening? The square left value is stored in the result. So the square left value is stored in result, and where it will be stored? It will be stored in the new array that is result, and index number will be holded by this ith value. Similarly, as soon as this value is being stored, what we have to do now? You don't require that particular element, so you'll be shifting the pointer. Now, since square left value is being stored, we shift the left pointer, and left pointer will be always moved towards forward. Nothing but what you have to do? You have to increment the left pointer. And if your condition goes false, what you have to do? You have to do the reverse of it. Else, in the result array, you will be storing the square right value, and based on that, the right pointer will be moved. So right pointer will be decremented over here. And this whole process will continue until and unless you come out of this particular loop. Means your I value is less than 0. Until and unless you will be always calculating these two values and comparing it and storing in the new array. So this what is happening. And once you come out of the loop, means your total result array will be fulfilled by its squared term, and you will be returning that particular array. So just return the result. So this is the basic logic about its question. We'll just see a dry run over here using this new example. So what we have done? We have left pointer at 0. We have our right pointer at n minus 1, nothing but at the 4th position, and my I is nothing but n minus 1, so I value is also 4. We have two variables, square left and square right. So these are the things which we are having on a question. Now, in the very first step, as you enter in the iteration, first iteration, so I'll just write it down, iteration 1, where my I value is 4, otherwise I'll write it here. So we see our iteration 1, where you have your left value as 0 and right value already we have initialized. We start with the iteration where my I term is 4. I have two variables taken, square left and square right. So first I calculate the square left value, that is nothing but nums left into nums left. So left is at 0, so nums 0. Nums 0 value is minus 7. So minus 7 into minus 7 gives me 49. Whereas square right is pointing at 4, and 11 into 11. We see square right, that is right is pointing at 11, so 11 into 11 square is nothing but 121. Now in the next step, what you do? You go for comparing. What we are comparing? We are comparing 49 and 121. So we say if 49 is greater than 121. So this is condition goes wrong. So directly you come to the else condition. What you do? You store the square right value, and where we are storing in a new array, that is result, and what is the position? Fourth position. So means nothing but at result fourth index, the value that to be stored is 121. So we directly see over here and you store the value 121 over here, and then what is happening? You are decrementing the right value. So right value is decremented from 4, it becomes 3. So this is nothing but your first iteration. And while doing this, what is happening now? For the second iteration, my I value becomes again 3. So the same thing happens again. You take square left and you take square right. Square left was already 49 because there is no movement, whereas right pointer has moved to third position. So nothing but you pick up this value now. 3 into 3, nothing but it's 9. So you compare, 49 is greater than 9. The condition goes true. So 49 is stored at the ith position in the particular array, that is result. So 49 is stored over here. And since this is the left value, what is happening? There is a movement in the pointer. So left is incremented and left value becomes 1. And similarly, my ith term will be now 2. It is decremented over here. Now what is happening? As there is a movement in the left pointer, now left points over here, and while calculating my square left, what will be happening? I'll be picking up the value that is minus 3. So minus 3 into minus 3 gives me 9, and square right is already 9 because there is no movement, it is pointing at the third location only. So you compare again these values, and I said I am only comparing with greater than and less than. So the condition goes false, you move to the else position, and this 9 is being stored. So 9 is stored at the ith location, that is nothing but 2, and again my right pointer is decremented. Similarly, my I pointer is also decremented. Now the same again, since left there wasn't any movement, the square left was holding the 9 value only, whereas what is happening to square right? It will be using the value that is nothing but where the right is pointed. Right is pointing at the location 2. So you go with the 2. 2 into 2 is nothing but 4. Now you compare, 9 is greater than 4. The condition goes true. So this value will be stored. 9 is stored at the location 1. So 9 is stored over here. Now there is a movement in the left pointer comes to the second position, whereas I value is decremented and it becomes 0 over here. Since there is a movement in the left, what is happening? Left is pointing here at this 2 index number. So the square of that will be nothing but 4, and right will be already at the second position only, so it is also 4. Again the same thing, you compare, 4 is greater than 4, the condition goes false. You store 4 over here, and my I position, I index gets decremented again, it becomes minus 1. So while this iteration is going on, the same way the condition is also checked every time. Now what is happening? Minus 1 is greater than or equal to 0. This condition goes false, and you move out of the whole loop. And as you move out of the whole loop, what we are returning now? We are returning the result. So what is the result over here? Result is nothing but the process which we have totally done, that will be given back as an output. So you can just see the output, that is 4, 9, 9, 49 and 121. So this is the result that has been returned as a solution for this particular question. And since iteration of the whole array is done only once, the time complexity, as I said, will be big O of n, and the space complexity will be also big O of n because we have taken a new array to store the data.